Hello, today we're talking about optimization in Unity, because performance is a main aspect of any game. It's often happens that you download some assets from the asset store and see that it's not very optimized. So we have created free scene for you, so you can download it in the link in the video description and make your own experiments. We open it and let's hit play to see what happened. Okay, scene seems running quite fast, but see the statistics for better analyzing performance. What do we see here? Many people looking on FPS, but this value is not very good for measurement performances. It's better to see other things like batches and trees. What does it mean? Video card is quite different device from the CPU. It's working like a factory. So if you send a lot of tasks there, it will be more optimal than sending tasks one by one. Amount of times that processor talking to the GPU is called batches. Amount of trees is amount of polygons on the screen in Unity. So these two numbers will be very suitable to determine the overall performance. The third and quite hard thing is the shader complexity. Because shaders are very different and we can determine what is more performant or less performant because it depends inside the code. So we try to describe this later. Let's start. So first thing that we need to do is to switch quality settings. Let's go to Edit, Project Settings, Quality. By default, Unity set fantastic quality settings for every new project. This is the best settings, and of course it takes a lot of performance. Because anisotropic textures filtering is forced on, anti-aliasing is also turned on, and shadow settings is very high. But for optimization purposes, this settings is not very good. You can always turn them on after everything has been optimized. So let's switch into good quality settings and see how this affects the draw calls. Now you can see that amount of batches have been decreased about of 500, and amount of polygons or trees have been also decreased. We can even delete fantastic and beautiful quality settings for accidentally not switching to them. But this is not everything. By default, dynamic shadows is turned on, so you can see shadows from the objects like these shadows from trees. But for optimizing, it's not very good to leave them on, because we can't very affect performance of the shadows. It is a built-in feature. So let's just turn them off and turn them on after we have everything be optimized. So by now when we hit play button, we have 800 batches and 377,000 polygons on the screen. Let's dive deeper. We need to analyze our scene and see what we can optimize and what we can't. It is very good to have your scene organized, because with organized scene you can easily determine some aspects, everything that takes your performance. Let's hit play and try to disable some features of the scene. Let's turn off builds. You see it took about 200 batches and not so much polygons. Let's turn off rocks next. It took about 100 batches and 50,000 polygons. This is a really little amount. Foliage is not affected our scene very much. And the last thing is props. So we have turned everything off and figure out that the main performance is destroyed by terrain. If we turn them off, we have no batches at all. But of course it's forming main parts of our scene. So let's optimize terrain. Select terrain, go to terrain settings and let's have a look. We'll try to turn off the drawing trees. You see that trees really affect performance very much. It's about 400 draw calls and a lot of polygons. What can we do? Terrain have such settings like billboard start. That means that from some distance trees stop being real 3D mesh and become billboard. Billboard is a texture that faces to you and draws very fast. Let's try to change this value and see how this affects scene and performance. If we set 0 meters, it looks flat with no wind and very bad pure quality. But if we set about 70 meters, it will be quite okay and our eye will even not notice these changes between real mesh and the billboard. Also we have optimized about 100 draw calls, a lot of polygons by such simple setting. Okay, let's go next. Also we can try to figure out how our grass affect performance. The tail distance is the distance of drawing grass. If we set 0, we have quite good performance, but no grass. And if we set 80 meters, it's a lot of batches. Okay, let's try to set about 70 meters and check other terrain settings. Let's turn everything off to everything be saved. Okay, this one and this, which called detail resolution per patch. What does it mean? Every grass on this scene is not drawn one by one. It forms like a quad patch and drawing as this quad patch. You need to have special frame debugger tool that's very suitable for optimization. I'm recommended to use it very much. Let's turn to game mode, quick hit play, click enable it and see how scene is formed. Just drawing our terrain. Then next textures on the terrain. Our trees one by one. It's not very performance, but we have no other options in fact. And let's see how forming grass. You see it forming just like quads. And the size of this quad is called detail resolution per patch. We can increase it and this will decrease amount of batches of the scene, but not the polygons, of course. Let's set 32. It have been changed a little our scene, but it's not a problem. It can sometimes cause problem with lighting and shadows, but we should find the golden average, I guess, for optimization. You see, we have very optimized our scene by grass, changing only detail resolution per patch. If I turn 8 again, You can see amount of batches 315. If I turn 32, it's about 100 batches. It's really good result, as I think. So let's keep it. Next things is a base terrain form. Let's try to optimize shape of the terrain. For this we need to turn off trees and probably grass. But for this we need to save the tail distance about 0. Oh, it's also turned by the grass. Okay, it's not a problem. We have about 100 batches and 50,000 of polygons. For such looking scene, it's very bad value. Even if we turn on scene and see around, we will see that it's quite empty. Nothing is here, but the performance is quite low. We also can set wireframe mode and see the terrain took a really lot of polygons. You see. Of course, such terrain is quite detailed. We can draw it very accurate, like this. Okay. It's quite accurate editing, but it's a very bad idea to use high detailed terrains, because your terrain will be covered by the grass and trees and you will even not notice it. So let's check what we can do. First of all, let's check the size of terrain in meters. It's about 800 meters per 800 meters. The next thing is a height map resolution. This resolution determines detailization of height of your terrain. The more height map resolution will be, the more detailed it can be. It's very convenient to have height map resolution as big as terrain width or height. That means that we can use 124 per 124 height map. You can export RAW, change it in Photoshop, and import again. I did it for you, so let's just import already RAW, this terrain low called, and see how this affects the performance. Let's not forget now performance, trees, batches. Okay, let's try to find it. Terrain, import, terrain low. Okay, let's open it. Import. Yeah, been changed a little, but you see, amount of batches been decreased, and the amount of trees also. Not very much, but it's quite okay. Also, the main things about shape of the terrain is pixel error. Pixel error is a value that determines how terrain looking from the distance. I will try to change it, and you will see how terrain is changed on the distance. With the pixel error 1 is detailed here, you see hills, and with the pixel error about 200 there is no details at all. Of course, as I said before, all your terrain is covered by trees, rocks, other objects, so you practically not see these things. So you can just leave 13 value. And let's see how it changed amount of batches. Batches have been decreased by 50, and now amount of polygons is quite good. Okay. base. You can see with the turn on trees, the overall qualities have not been changed a lot. But we optimized a lot of draw calls. Okay. Also, terrain have so-called base map distance. What does it mean? As you remember, you can paint textures on your terrain, but from some distance all your textures become lower in resolution and Unity spends less rendering power and of course optimizing performance. If I change, you will notice it. Base map distance set to 0. You can see the performance. Practically no batches, small amount of polygons, but of course no quality at all. As you see, from some distance you even not notice the changes by changing base map distance. So you can set this value to 300 and leave it. So we have optimized a lot of batches and polygons by changing these terrain settings. And of course, if we turn on trees and grass again, we see that nothing have been changed a lot, because trees and grass cover by itself all our terrain. Let's go next and optimize buildings in this scene. So we need to turn them on to see how they affect on amount of bunches. As you can see, we turn on buildings and we got about 400 batches. Without them, 150 batches. So there are really a lot affecting performance of our scene. So let's check how they design it to see what we can do. As you can see, our buildings created from a lot of different small parts, like walls, windows, tiles, and planks. Each time processor spend time to say GPU to draw these parts, so this slowing down our performance. What can we do? Unity can combine such objects into one if they share same texture, material, and all same properties. And call it static batching. Why static? All objects that should be combined should be marked as static and will not move in the scene. This means that we can animate them, use them in the physics, or other moving. As you can see, static can be applied separately for each part. But our buildings created from prefab, so we can just turn static option on and apply for wall building. Yes, change children for all. Change, and change. This building is not connected to prefab, it's a separate object and already set to static. So let's check and leave it. Now everything is marked static and we can test our performance. Let's hit play and see the result. As you can see, result is dramatic because amount of batches been decreased a lotly, and Unity said that he kept a lot of batches here. We can even see step by step how he made it. We can use a tool called Frame Debugger, click play and see the result. Okay, it's played, click enable it and see. As you can see, these parts of such buildings combine all together because they're same texture, same material, so Unity decided to draw as one batch. wall, even walls from neighbor houses been drawn as one, according to static batching. Of course, static batching is limited because we can move such objects, so they should be static. As you can see, it was very simple to optimize such buildings, but some guys just forget about it. Okay, let's check our rocks. They also don't static. Let's mark them as static because they're not moving our scene. We can do it by this. Prefab, mark and mark as static. That's it. All our rocks is static now, but they don't turn on. What can we do with rocks? Let's try to enable, disable them to see what can we do. Rocks already marked as static, so static batching combine them all into one mesh. So by batches we can't optimize much more, but we can optimize by polygons. How can we do? Let's go into scene mode, turn on wireframe mode, and see the geometry of our rocks. For example, this rock very detailed, and from distance mesh become more and more dense. The common practice in game development is to replace models from the distance with lower quality, smaller amount of polygons or textures or other ways, maybe simplified shaders, and call it LOD, level of detailization. And to support this feature you can set up LOD. Let's check how we can make it. First of all, let's go into normal view, shade it, and select this rock. It is a rock 14A. Select it. Here it is, but it's a prefab. We need a model. We have about 1300 polygons. It is quite a lot. We need the same model with smaller amount of polygons, but looking quite the same. How we can do this? 3ds Max have special modifier called Pro Optimizer, which can be applied to 3D model and simplified automatically your mesh. Of course, it can cause some lighting troubles and UV troubles, maybe deforming. I don't know, maybe Blender have such options. You can comment it if you know it. I made already LOD for you in 3ds Max, and let's set up it in Unity. We need to create an empty object. Create empty. Let's call it rock 14. Replace it and attach this object. Should be position 0, 0, rotation 0, 0, and scale 0, 0, 1, 1, 1. Okay, what can we do next? We need to rename this prefab into LOD 0. LOD 0 called the best detailed model, best quality. Okay, let's make second LOD. This is complicated mesh, so we need to break prefab, delete it a little, clean up. Let's call mesh. No, it's wrong mesh. Sorry. This should be deleted, and this called LOD 1. LOD 1 is a second detailization that should be applied from some distance. Okay, we have no material, so we need the same material for our rock and LOD, like this. You see, even this, from visualization, difference is not big. Then you need to add for your root object LOD modifier, LODs. By default you need to have a lot of LODs, LOD 0, LOD 1, LOD 2. So, but we have no very simplified 3D model. Let's LOD 2 just remove, delete. What does these numbers mean? You need to analyze which percent on the screen takes by the object, and according to this percent on the screen we can decide which 3D model will be used, or cooled or disabled at all, this mode. Okay, so we need to tell that with this detalization we should use LOD 0. With this detalization use LOD 1, and cooled will be automatically. That's it, we don't need anything else. As you can see, now we have LOD 0, and from some distance it becomes LOD 1. Because we can notice it, so we can just tweak it a little to be less noticeable. Like this. Yeah. Okay. Also we can rename our prefab into loaded, and make prefab again, because we crashed the original one. Rock 14, loaded. Okay, we made it. The next big problem in Unity is that rocks already been set up, placed on the terrain, and connected to its original prefabs. We can't change prefabs on the disk adding these LODs. It will crash anything and we lose our placement. That's why we create a special script extension for Unity editor that allow you to replace objects in the scene, keep it position, rotation, scale with prefab, and make connection to that. How it works? Let's check objects that we should replace with LOD. This one, I guess. As you can see, we are quite often using Rock 14 in this scene. And go into Doctrina hardcore menu, replace selected. Here we should place prefab that should be replaced, all of these objects, rock loaded, and click replace selected. Now all the rocks replace it with prefab that we selected. Everything kept, even renamed, and have LOD. This script extension included in the scene you can download in video description. Let's see how this affected our scene. In fact, every rock that plays here in the scene already have LODs, because it's quite a lot of time spent to set up each one. Yeah. Some rocks have just cool mode, so from distance we have not simplified model, but we completely remove rock. Like this, you see? Let's check this one rock. Just cool it. If we select it, cool it, LOD 0. So if we click play, we have a little improvement in polygons on the screen, because all other rocks already in fact have set up with LODs. Also we can use such techniques for our buildings too, and it's already been used, because buildings are very intense on polygons, especially this tile on the roof. It have also LODs. If we zoom, you can see there is a lot of polygons. Let's check how many. we scale it, replace with a small detalized object. Of course, as much LODs as you add, this transition will be smoother. It depends on your artist and people who made the sets. So we already have optimized a lot. Let's check what have been left. Foliage and props. Let's turn on foliage. As you can see, it took not so much draw calls. But anyway, let's check them. First of all, let's see what. As you can see, every object is quite simple, so the only option that we have is to set them as static, because these objects are not moving in our scene. Let's do it by prefabs and set static. Okay, that's it. If we check polygons, oh, we have quite a lot of polygons, but we have not so much hanging ivies in the scene. You can build your own LOD for this, for example. And let's check other utilization thing. Hanging eye. It's very simple. Small amount of polygons, but quite nice looking result. Let's check. What do we have now? It's okay. And the last one is props. This amount of bunches and trees. And let's turn them on. Not very big performance impact, but we can try to see what can we do. Let's turn them on and check. It's quite simple models, not very complicated, not modular. Let's check this one. They already combined as one, and this. What can we do? We can mark them as static. Let's check prefabs and mark prefabs as static. Yes, select all of them static. Okay, this one, select. It's not a prefab. But created from model. Okay. We can do by this clicking static, but we're losing prefab connection sometimes. For example, for this fence. So if you next time will create it from the prefab, you will lose the static option. So don't forget to mark prefab as static. Candle. Yes. This one. This one. Yes. Okay. We marked everything, I guess, static, and let's check amount of. It's quite okay. As you can see, saved by batching a lot of objects, so we do it efficient. That's it about batches and 3 polygons, but we have something more to optimize. Okay, what's about video RAM usage? Let's hit play and see tool called Profiler to determine how many video memory been used in this scene. Let's check rendering option and see. So about 200 megabytes have been used for this scene. Of course, modern video cards have a lot of video memory, but don't forget about mobile or embedded video cards or extension of your scene in the game in the future. So try keep it as efficient as possible. Let's try to optimize this even now small value. Okay, what can we do? First of all, let's check small objects on this scene, like this lantern, and check its materials. It's quite okay size, but you know it's very simple and small. So if you plan in a third person game, this object will be really small, so you can turn just smaller texture size. It's about this one, without losing quality view. As you can see, nothing have changed at all. Yes. Let's check this one. It's too big. It's really too big for just a log. So let's turn to this one. And you see how video RAM usage have been decreased. This one normal map should be decreased to okay, at least by twice. It's quite normal size for such a big object on the screen, so let's keep it. Okay, let's go next. It's quite big size, so we can of course slice it by half like this and slice into this. Okay, and losing nothing in fact. Okay, what's next? We can reuse same texture. It's okay. Let's check candle. It's okay size for small candle. Let's check ivy things. It's quite okay. It's one big texture. Oh, it's not reuses one texture, but anyway, it can be modeled better, but we can't do anything here in Unity. Rocks is very big, so we need as big texture as possible. In fact, let's check which size been used for. It's not very big size, in fact, so it's okay. Okay, these things, modular small things. It's quite okay. That's it probably in our scene, so we just can leave it. Okay, it's what about small objects. Next things is trees in Unity and how it uses it and what it uses it. Let's find them on the disk. Projects, foliage, and for example this tree. For every tree, you need to generate textures. In a folder, this. Let's check them. We have one for diffuse, one for normal map, and one for shadows and translucency. By default, these texture generate very big, like this one. And you need to use such big texture every time you draw a tree. As you can see, this texture is empty because we don't provide special textures for translucency, so it have no sense to keep it such big. Let's set small resolution, but keep it for everything works fine. And check other trees. Turn smaller resolution, turn smaller resolution, here apply, tree 4, what it is, no shadows as you can see, can just decrease. Too much detailized normal map I guess for trunk, it's a dead tree and this normal map is the size of the picture. We can decrease, I guess like this one. Yeah, nothing have changed. Okay, let's see others. Small, small. Ground cover. This should be smaller. I guess we don't need these textures because we deleted some prefab, so I will delete it. That's it. No normal map. Weird. Okay, so we can just set small resolution, shadow keep, big diffuse. But let's take a look on this foliage. It's very small and use edge separate texture, so we can decrease size, I guess, like this, and nothing have been changed very much. Yeah, this Fern, let's check Fern. It's also it's very small, so we can decrease resolution. Normal have no normals, so just turn them off. Like this and like this. Okay, next is a bush, also small, not so big. Let's decrease size. Okay, no specular, no normal map, and small translucency. That's it probably, I guess. We changed all of them, and let's check how this affected our scene. Hit play and go to Window, Profiler, Rendering. It's not so big changes, but there is changes. If you have a lot of different trees, objects, you should keep your textures according to the size of the objects on the screen. you propose to user will see it. So try to keep video RAM usage smaller as possible. Also, you can force Unity to use same textures for different trees, but the trees have combinations. For example, tree 2 have absolutely same texture like tree 1. Let's check this. This and this, this and this, this and this, this and this. So we can force to use other materials, I guess. Here it's already used first theory. So it's quite optimized in fact. We have kind of luck. Okay, it's already been optimized, so we now need to optimize it. Let's check again. Window profiler, rendering. Such small optimization will be efficient too. Okay, even now we have even more options to optimize. Let's check them. If we turn game mode and hit play, only objects that you can see on the screen will be drawn, and this affected on batches. But the objects behind the camera or left or right is not drawn. That's called Occlusion Culling. Unity do not draw objects that is not in the screen. But as you can see, this big rock, yeah, and some objects can be placed behind this rock. Let's check what we can see behind this big rock. It's a small house, but detailized. A lot of trees, a lot of different other rocks you can see, and all of them will be drawn, because it's very hard to understand that what we should render and what we should not behind one objects and others. But Unity provides technology called Occlusion Culling that help us to remove objects that are not drawn behind others and made our scene even more efficient. How to set up and work with that? First of all, we need to mark all the objects as static. We did it already by mark it as static. Rocks, static, as you can see. This one static, and the objects behind this, like this house, is also static. So we are ready to make this culling. All we need is to go to Window, Occlusion Culling, and check what do we have here. Let's go to Bake and see everything is set into default. I recommend to set 4 smallest occluder size, backface threshold by default set to 100. Let's move it to 5 and click Bake. Now you need to compute in Occlusion Culling and how it will affect our scene. Here you can see the process of the building. Depending on your scene, this could take a lot of times, in fact, so be patient and try to optimize your scene during creation, but not in the end, of course. Computation is now finished, so we can check the results. Let's hit play and see the statistics. It's not changed very much, but we keep several draw calls patches. Let's check what objects are not drawing here now. There is a visualization turned on, and you can see the every object behind the camera is not drawn, except grass. Anyway, it's drawn because we set quite big detail resolution per patch, and anyway they are drawn. But this house is really not drawn. Billboards are not affected by occlusion cooling, so they are drawn as well. Some rock disappeared here, as you can see. If we turn off visualization, we can see the difference. Oh, too many. This house, rock smalls behind this big one, is drawn by default. Let's check performance. Occlusion cooling is very efficient in labyrinths, houses, caves, closed environments. On such open spaces, sometimes not very efficient, so it's very useful in quite different scenes, but anyway you should use it because it helps to optimize and make your scene more efficient. Next thing is shaders. What can we do and how to use them properly? Okay, Unity 5 has introduced some special new cool shader called standard and provide by default for any new created object. Let's try to create some object in the scene, like sphere. Here it is. And as you can see, the sphere have standard shader. It's quite hard, complicated, but provides more realistic lighting model, so-called physically based rendering, PBR. Okay, let's destroy the sphere and see what do we need. But for working these shaders properly, in fact you should build lighting for each scene. By default, this building is automatically with this checked option. But we turn it off because it took sometimes a lot of performance and waiting times. So to work our shaders correctly, first of all we need to build lights. But if we keep everything turned on, we can lose so much performance and wait a lot. So let's try to disable decor and build lighting. Window, lighting, settings, generate lighting. That's it. Nothing especially have changed because for vegetation and grass Unity do not use these shaders because of performance. Let's turn on decoration and see the difference. I don't know, have you noticed, but lighting of the rocks have been changed, became more brighter and more reflective. Houses have not changed because they do not use standard shaders. Instead they use legacy shaders, bumped, more simplified, not so great looking. You can see this nice metal object. Metal objects is very grateful for using with standard shaders, and you can really achieve great looking metals. So if you need such complicated materials like plastic, glass, metals, you definitely need these shaders. For some other object like bricks, walls, stones, it's not necessary to use such complicated things. So keep in mind, shader complexity we can determine its performance because it depends on video card, and Unity have no option to determine complexity of the scene. By the way, you can check which shader have been used and which texture and parameter it provided. How to do this? Click Game Mode, click Play, and go to Frame Debugger. Enable it, and here you can see which shader have been used. For terrain, let's check not our terrain, but something else. For example, Lantern. This is standard shaders. As you can see, has a lot of different parameters. Stone also is very complicated. So here you can check which shaders have been used and how they affect the whole scene. Sometimes it's hard to determine which shaders to use. Depends on the quality, on drawing. So it's just your choices what to use. But always keep in mind the overall performance. For example, you have no need to use standard shader on the grass because you probably don't even notice it. But video card still will calculate all the things and parameters provided into shaders, so it will lose your performance. We can keep such rocks. I think it's better looking, but something a little bit too much reflective maybe, I don't know. As you can see, I can control reflective parameters of the rock by controlling smoothness. Okay, leave it, as designer made it, so just leave it. Maybe they are very wet after some rain. That's it about shaders. Last few words about optimization. Let's check terrain and see what shader does it use. By default, if you not change properties, Unity is using built-in standard shader. But as we mentioned before, standard shader is quite not optimal for such looking things. So we are mostly commonly use built-in legacy. It's also provide bumpness on the terrain like these small rocks. If you need some wet effects like rain, you can use legacy specular. It's quite faster and allow you to make such wet grounds. Let's turn on legacy diffuse to minimize shader computation on the GPU and see next things. Also, one big optimization things is clipping plane. Clipping planes and distance from which main camera stop to render things. Of course, it can minimize draw calls, batches, and amount of computations. Let's check how that works. By now we have 200 batches, and let's check this. Now we have 28 batches, but of course we can see half of the scene. It's not suitable for probably any game. But this value can be of course different. If we have 100 meters, now we have less vertex data and polygons, lower amount of batches, but our scene stopped to looking just right here. This effect affects visual quality, so it's on your own to see to change clipping planes, of course. It's 200 meters check. It's not enough, of course. If you have not big far clipping plane, you can compensate it by the fog. Fog is not very hard effect for the GPU and CPU, so you can use to make smoother transition between clipped scene and all your environment. How does it work? Now fog is turned on, and the color of the fog the same as the down color of the skybox, this and this. By this we can make a smooth transition between sky and the fog, and of course we can increase fog density to make transition smoother, like this. Yeah. It's quite realistic, but your scene is clipped and not dropped in some distance. I'm just back all the values like they were before. because it's not affect our scene very much, but sometimes you can use this effect too. Next thing is terrain. Amount of detailed textures being used to draw on the terrain. This value is better to keep 4, 8, 20. Why? Because Unity storing data which texture will be drawn in such textures and use red, green, blue and alpha channels to determine which texture will be drawn at this point. So if you use more than 4 textures on the terrain, it will be quite not optimal, because you need to generate extra texture, huge enough, and generating extra batches. So it's very bad idea to use 5 textures on the terrain. Try to keep it 4 or 8 or 12. Also 1 texture is bad, 5 is bad, 9 is very bad. So try to keep it 4 and use all the possibilities the terrain system gives to you. Okay, we have optimized a lot of things, so it's time for shadows. Let's turn them on. But before, let's check amount of draw calls and the polygons on the screen. Edit, project settings, quality, shadows, hard shadows only. Now we have shadows. Amount of batches and polygons have been increased by 2. Shadows is a main performance killer in any Unity game, so be very accurate with them. By default, shadows set at very high resolution, so they just kill all your performance and make your game unplayable. How we can turn and optimize them? First of all, shadow resolution. Shadow resolution affect only on the quality. If we set very high, you will probably notice that we see every branch from this tree. But we don't affect the batches and polygons. Amount of computations being increased inside GPU. So we can even see some birds, some numbers to determine that performance have been decreased. We prefer to use medium resolution because for common video cards, old new, it's quite okay resolution. Stable fit or close fit. It's probably stable fit better using by default. Shadow distance is one of the main features to optimize shadow. If we set 0 distance, we have no shadows at all. 10 meters, we have shadows only on 10 meters. But of course you can see transition between shadows and no shadows. But the amount of batches and polygons anyway have been increased a lot. We also set 40 meters being optimal value for such scene, but you can turn for your scene your own. Let's check. We try to set a lot of distance, been 200 meters. You see that even far objects have been shadowed, but the quality and the near have been decreased a lotly. So it's some balance to find value. 40 meters for us is quite okay. 2 cascades and no cascades. By this parameter we can change the value have been used in performance inside GPU. With no cascades we have less batches, but amount of amount of calculations inside GPU have been increased. With 2 cascades and the near plane, Unity renders shadows with higher resolution and from some distance render shadows with lower resolutions. This distance you can affect by this control. As you can see, if we decrease percent for 0 cascade, we have more detailed shadow in the near plane, but less detail at the far plane. You can leave default value with 33 or tune it little much for 20. That's it. Thank you for watching. Hope you will use all the information. Thanks to guys who made fantastic free assets like rock boulders, these trees and grass. Hope you will use all of them all sets, because we changed them a lotly. The links to all of them will be listed in the video description. You can download, analyze them by yourself, and probably use in your cool Unity project. Bye.